Today we are going to learn an important topic from graph theory, which is part of data structures and algorithms. The topic we are going to discuss today is adjacency matrix. This topic is very important for exam, interviews, and also understanding how graphs are represented inside a computer. If you are new to graphs, don't worry at all. I will explain everything step by step using clear example. By the end of this video, you will clearly understand what an adjacency matrix is, how it works, and where is it used. So, let's get started. First, let us understand what a graph is. A graph is a nonlinear data structure. A graph is used to represent connections between objects. A graph has two main components, nodes, also called vertices, edges. Nodes represent the objects, edge represent the connection between those objects. For example, in a road map, cities are node, road are edge. In a social network, people are node, friendships are edge. Graphs help us model relationship in an easy and visual way. Let us define the adjacency matrix clearly. An adjacency matrix is two-dimensional array used to represent a graph. If there is an edge between two nodes, we place 1 in the matrix. If there is no edge, we place 0 in the matrix. So the matrix tells us about the presence or absence of edge. This is very simple and direct way to represent graph connection. Now let us talk about adjacency matrix representation. An adjacency matrix is a way to represent a graph using a square matrix. This matrix helps us understand which nodes are connected to each other. The matrix contains rows and columns. Each row and each column represents a node in the graph. Using the matrix, we can easily check whether an edge exists between any two nodes. Now let us look at nodes and edges more clearly. Nodes, also called vertices, are the individual items in a graph. You can imagine nodes are point or circle. Edges are the link that connect to two nodes. Edge shows how the two nodes are related. An edge can be directed or undirected. In this lesson, we mainly focus on undirected graphs to explain adjacency matrix. Understanding nodes and edge is very important before learning graph representation. In the adjacency matrix, each row represents a starting node. Each column represents an ending node. If the value at row I and column j is 1, then there is an edge between node I and node j. If the value is 0, then there is no edge. This makes it very easy to check connections in a graph. Now let us understand what 0 and 1 mean. 1 means an edge exists. 0 means no edge exists. For example, if A is connected to B, then matrix AB is 1. If A is not connected to D, then matrix AD is 0. In undirected graphs, the matrix is symmetric. That means if A is connected to B, then B also connect to A. Now let us look at a simple example graph. This graph has four nodes. A, B, C and D. Connections are A is connected to B and C. B is connected to A and D. C is connected to A and D. D is connected to B and C. This is an undirected graph. We will now convert this graph into adjacency matrix. Now let us build the adjacency matrix. First, we write the nodes on the top and left side A, B, C, D. Then we fill the matrix. A to B is 1, A to C is 1, A to D is 0, B to A is 1, B to D is 1, C to A is 1, C to D is 1, B to E is 1, D to C is 1. All other values are 0. This matrix clearly shows all the connections in the graph. Now let us look at the advantages of adjacency matrix. First advantage, it is easy to understand and implement. Second advantage, checking whether an edge exists between two nodes takes constant time, which is 0. Third advantage, is useful for dense graphs where there are many edges. Because of these reasons, adjacency matrix is very popular. Now let us look at the disadvantages. First disadvantages is it is use a lot of memory for sparse graph. If a graph has few edges, many cells will contain 0, which wastes memory. Second disadvantage, for large graphs, the matrix become very large. Third disadvantage, adding or removing nodes is expensive because the entire matrix must be rebuilt. So it's the best choice. Let us summarize what we learned today. A graph contains of nodes and edge. An adjacency matrix is a square matrix used to represent graph connections. Rows and columns represent node. Value 1 means an edge exists. Value 0 means no edge exists. Adjacency matrix is easy to use and fast for checking edge, but it uses more memory for sparse and large graph. I hope this video helped you understand adjacency matrix clearly. Thank you very much for watching. If you found this video useful, please like, share and subscribe. See you in the next video. Bye bye.